Many regions in the world are facing, or will soon face, physical water scarcity as competition for water resources between agriculture and expanding industrial and urban water needs grows. Oman is addressing this growing imbalance in an innovative manner. Omani company, trading and investment establishment, has partnered with Australian Rain Technologies to conduct a rainfall enhancement trial using ART's Atlant technology in Oman. Most importantly, these trials will produce usable results on which to determine the potential applicability of rainfall enhancement to Oman's water needs. The Oman Rainfall Enhancement Trial builds on ART's series of similar trials in Australia, which yielded significant results and increased rainfall in a protected environmental area threatened by water shortage. In each of the three trials, enhancement of around 10% was shown, at levels of statistical confidence of 90%. In Oman, a pilot trial was conducted in 2013 with an independent evaluation of the results by the National Institute for Applied Statistics Research Australia at the University of Wollongong. This showed increased rainfall at levels and statistical confidence comparable with the Australian trials. A partnership between the Omani government, TIE and ART has now commenced a 5-year trial, which is the most sophisticated investigation of the efficacy of rainfall enhancement in history. The 2014 results, deploying 4 Atlant units, mirrored those of 2013, with higher enhancement most usefully expressed as 18.5% across 2013-14, with similarly high statistical confidence. These initial results and the ongoing trial investigations are exciting not just for Oman, but for other nations seeking increased water supplies. Let's take a closer look at how the Atlant technology works to enhance rainfall. Under normal circumstances, rain forms when water vapor condenses around particles or aerosols in the air. These aerosols or cloud condensation nuclei are typically very small, only a few microns in diameter, and the initially formed cloud droplets are of similar size. Cloud droplets are circulated by air currents within the cloud, and as they collide and coalesce, become progressively larger. To fall as rain droplets, cloud droplets are required to increase in size up to 1 billion-fold. When they achieve a diameter in excess of 1 millimeter, they are ready to fall as rain. ART scientists' working hypothesis is that the Atlant system enhances the collision coalescence process and the growth of small cloud droplets into raindrops by increasing the presence of electrically charged droplets within a cloud. Cloud chamber experiments have indicated that coalescence between colliding drops is increased by the introduction of charged droplets, accelerating cloud droplet growth to rain droplet size. Negative ions are generated from a ground-based high-voltage corona discharge wire array. The ions attach to passing particles or aerosols in the air. The charged particles are conveyed to the higher atmosphere by the wind currents. Once they pass the level at which clouds are forming, they become cloud droplets in the same way we saw earlier. Except these cloud droplets carry a negative electrical charge. The ART hypothesis proposes that the presence of both charged and uncharged droplets in the cloud increases the rate of collision and coalescence between cloud droplets, resulting in an enhanced raindrop growth rate and ultimately increasing rainfall downwind of the Atlant ion emitter. The initial trial in Oman was operated in the Hagar Mountains between May and October 2013. This period captures the high incidence of convective storms with consistently suitable microphysical conditions for rainfall enhancement operations. This region was chosen considering synoptic and local wind flows, cloud types, widespread uplift, and moisture availability. Such features affect the delivery of charged particles to the cloud layer and subsequent rainfall enhancement. To collect data for the trial evaluation, TIE installed a sophisticated network of meteorological observing equipment. This included 120 rain gauges and 2 automatic weather stations in the trial area. To this, data was added from 11 weather stations operated by the Oman Directorate General of Meteorology and Air Navigation and daily upper air sounding at Seeb International Airport. In 2014, 30 additional rain gauges, 2 additional weather stations and 2 SODAR units to measure vertical wind profiles above the Atlant sites were added to the observation array. Statistical analysis of trial data was carried out using spatiotemporal models, which used meteorological and spatiotemporal covariates to capture natural rainfall variation, enabling estimation of the level of enhanced rainfall attributable to the Atlants. This methodology was originally developed to analyze the rainfall enhancement trials in Australia using dynamically defined target and control areas. It has produced significant and usable results. Analysis of the Oman 2013 trial data showed statistically significant rainfall enhancement attributable to operation of the Atlant systems at an estimated 18%, generating the confidence to expand the trial to further areas of potential benefit. The 2014 trial analysis and results mirror the 2013 results. The comparison of rainfall rates displayed here are with and without the Atlant system. The areas affected by Atlant operation showed increased rainfall, resulting in greater runoff into the wadis and higher fill rates for dams. In each year of the 5-year trial, which commenced in 2014, 2 more Atlant units will be added. This allows scope for ongoing development of the Atlant ion emitter design. The number of units, the areas covered by them, the length of trial, and the sophistication of data gathering equipment make this trial the most comprehensive ever conducted in the history of rainfall enhancement. If the 2013-2014 results are repeated in the remaining years of the trial, Oman will be in a position to deploy the Atlant technology as a key component of providing for its water needs at very high cost efficiency. Embracing this new technology is an opportunity for Oman to lead the way in addressing one of the major issues faced by water-deficient nations around the world.